All right, now we have a 1/3, a fraction, raised to the x power plus 1. Now, for this particular table, what kind of x values would you suggest? Ooh, why negative x values? Why negative values? It makes the number larger because the negative x value means you have a negative reciprocal, which is negative exponent, which makes it a reciprocal. So let's go ahead and create some nice negative values. All right, let's just say we have. Let's work with these two first. These three first. 1/3 to the -2 power. All right, so give yourself a moment. Can you think? Can you get what is 1/3 to the -2 power? That's equal to 9. Okay, you do the reciprocal. 1/3 becomes 3. That's a negative power. And then you square it. So that's 9, which is 10. So at -2, it is 10. So somewhere up there off the chart. Okay, unfortunately. And then 1/3 to the -1 power plus 1. 1/3 to the -1 power is simply 3. So 3 plus 1 is 4. So when x is -1, we have a number 4. And 1/3 to the 0 power plus 1 is equal to 1 plus 1, which is 2. All right, so let me pause a moment right here and fill in some blanks. So we do have a y-intercept at 0, 2. It didn't ask for transformations, but I think we can show our transformation right here. There's only one, which is which direction? Up 1 unit. So therefore, the horizontal asymptote is y equals to 1. And if you go ahead and now you may, let me put in the values first. You may go ahead and consider what is x to the first, x being 1. So 1/3 to the first power plus 1 is simply 1/3 plus 1, and that is 1 1/3. So something like this would be okay. So if you create a graph, it's going to be something like this. Okay, so the domain is going to be from -infinity to infinity, and the range is from 1 to infinity. And as you see here, the graph goes from left to right, and the graph is going down towards the y equals to 1. So this is clearly a decay. Okay, this is clearly a decay. Do you know if you have a hot cup of coffee put into room temperature, of course the coffee would cool down, okay? And it does not cool down linearly. It cools down really quickly at the beginning, just like this graph right here. And then as it gets closer to the room temperature, it cools down slower. So if you have the opportunity to study calculus, you will learn that kind of behavior in calculus.